I'm Anil Kumar, sharing with you some brilliant questions from previous test paper. Here is question number 8 from a test paper of my IB student. I hope its solution will help many of you, right? So here is the question, which I have copied, and we'll try to see how to solve such a question. Question number 8 is, find the value of C algebraically such that f of x is continuous for all real numbers. Sketch the functions. So we are given f of x equals to 2 minus x squared for x less than equal to c and is equal to x when x is greater than c, right? So for this function to be continuous, what should be the condition? Well, if I substitute c, I should get the same value. These are the two legs, right? They should match up at x equals to c. So basically, 2 minus x squared should be equal to x when x is equals to c, right? So we can substitute c here and then get the value of c. So we get 2 minus c squared equals to c. Bringing them together, we get c squared plus c minus 2 equals to 0. Now, minus 2 and sum, we get 2 times 2 and minus 1, right? So we can get this as c plus 2 times c minus 1 equals to 0. That means c is equal to minus 2 or c is equal to 1. So there are two values of c. So for two values of c, we definitely have two functions, correct? So one of the functions will be, let me write here, f of x is equal to 2 minus x squared for x less than equal to c is, let's say, minus 2. And here we have equals to x when, I should write, you can write x also, right? So x is greater than minus 2. So that is first function. The second function, which will be continuous and will meet this condition, will be 2 minus x squared when x is less than equal to 1 and is equals to x when x is greater than 1. Right? So these are the two functions. Perfect. So we got two functions. Now second part of this question is that we need to sketch both of them. Right? So this is function 1, that is our function 2. Now let's try to sketch them. So I'll just make a rough sketch here. We'll have two graphs. Okay. So the first one here is, we'll consider point at minus 2. So at minus 2, x value is minus 2 and it's a straight line and is greater than minus 2, right? So this is the value of this at minus 2. Let's say this is minus 2, okay, for us. So, all right, I'll do the first one here. So this is minus 2. So we have a straight line, x is greater than minus 2 is x. So at minus 2, we have a point which is a hole, right? So let's have a hole here, right? So if I write this as 0, it will be 0. So this is a straight line which is going like this. Now when it is less than minus 2, it's a parabola. X squared 2 minus x squared, right? So 2 minus x squared, so parabola. So if I write minus 2 here, I get this as square is 4. So 2 minus will be minus 2, right? So we have the same value. So for this function, let me use a different color, okay? The second leg will match, correct? So that is why it is continuous. And if I write a value 3, in that case, well, this is a parabola which is kind of like this. From 2, it is going downwards, right? So this is going to go like this, downwards, right? Definitely, it's a good idea to have another point on this. So if I write 3 here, 9, 2 minus 9 is minus 7. So we can have this point which is minus 3 minus 7. Is that clear to you? So that's the parabola part. So that is your function f of x, one possibility reflecting equation 1. The second one here is when x equals to 1, then we have these two legs joining up, right? So this is the value of x equals to 1. So on the right side, at 1, the value is 1, so it is not filled in, and it's a straight line. On the left side, it is a parabola, which takes this value of 1 at 1, and it is kind of like this, right? Correct? So at square root 2, it will have this x-intercept, right? Not at 2. Let me write this as minus square root 2. To be precise, this value will be 2, and here we have 1, 1. Correct? So that becomes the second function as shown here. So it's a combination of a parabola which is opening downwards and a straight line which moves right diagonally. Correct? So that is how we could actually solve this question, and I hope you find it interesting and useful. This is one of the unique examples where we are finding the continuity of the function and the limits are to be found. Perfect. So I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.